Greeting to all the judges, organizers, and fellow friends. We are Team 666 from Penang Chinese Girls Private High School.
Hello judges, my name is Xuan. I'm the team leader of Team 666. One of my main roles is to construct and test out the ship. Besides that, I also help to monitor my team members.
Hello judges, my name is Evynne. One of my main roles is helping my team leaders in editing this video.
Hello, I'm Kong Xing-er. In this project, I mostly help to design the shape and search for information.
Hello, my name is Hueyi. I am in charge of writing the coding for this project.
Hello judges, my name is Evynne. I'm a team member of Team 666. I'm in charge of preparing the flowchart diagram and explain about it. Besides, I also help my team to make the PPT and build the ship.
This is the contents that we are going to present in this video. This is our team. We give a name to our project, which is Jack2 Ship. Our project's theme is to build an accident-preventing ship by using waste and recycling materials. We hope to achieve two objectives throughout this project. Firstly, design a ship that can avoid the ship collide with each other. Secondly, to build a ship by using the recycle or waste material to align with SDG 12, which is to ensure sustainable consumption and production patterns. Now, I'd like to explain the problem statement to you. Through this report, you can see that the common cause of boating accidents is operator inattention. For example, there is an article about ship collisions that happen at sea in St. Queen's Bay. The reason for the collisions is precisely because of the operator inattention, since it has happened before dawn, which most of the people will feel tired and asleep during that time. Operator will lose focus during that time. Next, along with the SDG 12, there is a subtopic 12.5, which is to substantially reduce waste generations through prevention, reduction, recycling, and reuse. We must learn how to reduce some non-recyclable garbage and waste materials. Example, according to the above article, sustainable consumption and production of plastic has been continuously rising due to the COVID-19. Because most of the people will order food delivered online shopping to avoid going out, all these activities use a lot of plastic. Through the article, we know that the market size is estimated to reach $40.8 million by 2027. This is because disposable chopsticks are convenient and cost-effective, and people love to order food delivery in recent years. So, the more disposable chopsticks are consumed. Although the government often urges people to use reusable bags, there are still a large number of people who buy cheap plastic bags for convenience when purchasing items. It makes the global plastic market price is expected to expand at a compound annual growth rate of 3.7% from 2022 to 2030. And also, many young people like to drink milk tea in recent years. However, plastic cups for milk tea and boba straws all belongs to waste materials. Lots of the sea creatures dead because of it. Like turtles, they stuck up their nose with the straws and unable to breathe.
Next, I will present the robot specification. As you see, it is a Cytron Maker Uno. I stick it on the bottom part of plastic cardboard so that all the components can be arranged in a proper manner. The dimension of my ship is 31 cm in length, 14 cm in width, and 18 cm in height. There is a green breakboard and a Maker driver next to the Maker Uno. I placed the green breadboard in the center of the cardboard for easier connection with all the wires. There are two LEDs built into the cardboard. In between, there is a switch to start the voyage. As you see, there are 8 pieces of chopsticks attached to the cardboard at the side. It used to attach with the boba straws on the half-cut plastic bottle, like this. Furthermore, there are 2 LDRs on the front part of plastic bottle for the purpose of detecting light. At the back of the plastic bottle, we fixed 2 DC gear motors there. At the bottom part of the plastic bottle, we stick a lot of chopsticks to balance the ship and increase the buoyant force of the robot. For decoration purpose, there is a house, swimming pool and a rose garden on top of the cardboard. If you go in deep to have a look, you can see there is an armchair, calendar, picture and a clock on the wall. There is an indoor swimming pool attached to the house with local and WC facility provided. And do not miss out the rose garden which have a beautiful view. The concept of building this robot is linked to the concept of SDG 12 by making use of waste materials and recycling materials. The materials we use includes plastic bubble wrap, disposable chopsticks, boba straw, plastic bottle, used paper, and plastic cover. These materials are the common materials which can be easily found in our daily life. For example, the boba straw of the milk tea, the plastic bubble wrap of shipping, the chopsticks of the food delivery, and etc. We aim at cutting down unnecessary wastage and to support the idea of waste utilization. Building robot will uphold the green concept in our inspiration. The following table shows the total costing of our robots. Since we mostly use free of charge items, the total price of the robot just 62 ringgit Malaysia. This is the general view of my project.
The ship has 2 LDRs light-dependent resistors that detected incoming light. If both LDRs detected light, which means the light is coming from the front, the propellers of the ship will stop and 2 LEDs at the back will turn on. If the LDR detects the light coming from either direction, the ship will move to the opposite direction, so it will prevent accidents happen. In all 3 conditions, the ship will produce an alarm sound to alert the operators. This is our ship. It has 2 LDR sensors. When the ship detected something bright, it will turn left.
Programming software that we use to write the code is called Arduino IDE. This is overall view of the coding. Firstly, we define the electronic components to the respectively pins. For example, the left motor of the ship is assigned to the pin 4, while the right-hand side LDR is assigned to the pin A4. We also need to declare 2 variables for the readings of 2 LDR sensors in order to use the sensors. In the setup section, we declared the function of the components. For example, the 2 LEDs act as output function, while the LDRs act as input function as they send the signals to the Arduino board. We also activate the serial monitor so that we can monitor the readings of the sensors in the computer. In the loop section, the 2 variables read the values from the respective sensors. The serial monitors will print out the both readings. Here, it is coded that when the light source is from the front, which detected by the two sensors, both motors will stop. Both LEDs will light up and the buzzer will sound. Here, it is coded that when the light source is on the left, the ship will turn right. The green LED will light up and the buzzer will sound. It is about the same when the light source is on the right, just that the ship will turn left, and the red LED will light up instead of the green one. When the sensors don't detect any strong light source, the ship will just move forward normally.
Here are the photos and videos that we took during our constructing process.
We first planned to use an ultrasonic sensor for the ship, but with further experimenting, we found out that it's difficult to make the ship stop on water. Therefore, we changed our sensors and decided to use LDR sensors instead. In our second test run, we used the LDR sensors to change the direction of the boat. The ship is able to move and detect the light normally. However, the ship is easily influenced by the other light source from the surroundings. Hence, we decided to fix a barrier of PVC cardboard on top and do some decorations on it. This can help to prevent too much light to be detected by the LDR sensors. We only want the light from the front to be detected.
After we have attached the cardboard and complete our decorations on top, we test our ship for the third time. Due to the upper body of the ship is heavily, therefore the ship has higher center of gravity. It is very hard to balance when put on the water. It overturns easily. Hence, we decided to add more chopsticks at the bottom and the sides of the plastic bottle to keep the robot balancing. Finally, we succeeded. We plan to do some slightly changes to improve our robot if we have more spare time. We use insulation tape to wrap around the normal DC motor to prevent the water entering the internal part of the motor. In the future, we hope to buy water insulated motors which can be fully used in the water, so that it is more stable to use in our project. Besides that, the robot we have made doesn't include a reverse function. We hope that we can add on the reverse function for our robot in the future. Now, I will share what we have learned in this competition. Through the whole process, we face a lot of problems. For an example, we don't have a proper water tank to use for the testing purpose of our project. We forced to use a plastic bag to cover on a cardboard box to act as a water tank. Finally, we managed to borrow a kid's swimming pool for test run our project. Through the whole process, it enhances our thinking skills and problem-solving skills. We also learn on how to connect the wire correctly so that the electric component can work. Moreover, we have also learned to write coding to function our robot. Furthermore, we have learned to use different types of sensors and choose the suitable one for our project. Most importantly, we also learn about the SDG 12. We understand the importance of reducing and reuse the waste materials as it cannot recycle. Through the project, it also increased our awareness about sustainable development and lifestyles. That's all for our presentation. Thank you for watching and listening.